All right, so 2.2. And if you are still running a little bit behind, this is not a lengthy section. And we actually touched a little bit on some of this last class. So first thing, a definition. Complement. So complement of a set, let's say, call it A. So complement of a set A and the way we designate it is A, and up in the superscript, a prime mark. And when you see that, it is a different set than A, and it is read complement of A or complement A complement. You can say it either way, complement of A or A complement. But basically, it's everything that is not in A. So and we have to introduce a new set we have not talked about as of yet. It is set of elements and this is the new set we need to establish, universal set. So that's an N. That are not in A. So again, as I said, everything except what is in A, or on everything that is not in A, however you want to phrase that. But this idea of universal set, which we usually use a capital U with a kind of scripted ends on it to designate that, it's the universe. It's the biggest set possible, and that will change from problem to problem. But once you establish it, there's nothing bigger. It is the universal set that all sets live within. So using set notation, we usually use a scripted U. So I kind of got scripted ends, and looks like that. So that would designate universal set. So using set notation to define complement of A prime, it's going to be all elements X, such that X is an element of the universal set. And as we said before, that element will not live in A. So simple example, if I have a universal set and it's defined to be 1, 2, 3, 4, 5, the numbers 1, 2, 3, 4, 5, and A is the set of elements 1, 2, and A complement, didn't want 2 marks there, then A complement is a set of elements 3, 4, 5. Okay, any questions on that? Complement of A. And so by our definition here, the complement of the universal set would be the empty set. And the complement of the empty set, then therefore would be everything else in the universal set. So it's the universal set. All right. Now picking up with something we had worked last time, and we defined this subset. So, and I'm just going to rewrite the definition that we did write it down last time. So set A is a subset of a set B if and only if all the elements of A are in B. And it is denoted this way. So it's kind of a sideways U with a line underneath. Kind of analogous, and as it turns out, to kind of, because it kind of looks like less than or equal to. So by definition, a set can be a subset of itself. All we have to have is all the elements of one set to be in the other. So by definition, a set could be a subset of itself. Now, we worked out a problem last time on Thursday where I gave you a set with 3 elements and said, write down all the possible subsets of that set. And in doing that, we did establish that order does not matter. I can write the elements of a set in any order I want. That doesn't change it or make it a different set. And we came up with, for a set with 3 elements, that there were 8 subsets, and one of which is the empty set. So the actual phrasing that we use for that is trivial, which is trivially by definition, since there aren't any elements in the empty set, there's no violation of the rule for what it means to be an empty set or be a subset. So empty set's a subset of every set. And we just kind of wrote out what all the subsets were, and we came up with the 8 of them. So what I want to do is do this in a more systematic way, and then use some inductive reasoning to come up with a way to calculate the number of subsets to a set, any set. So we're going to go back and look at that problem that we looked at last time. So if I have a set A, and it's got the elements A, B, C, that is, it has 3 elements, or the word we use is cardinality. So remember, cardinality is the number of elements within a set. So the cardinality of this set is 3. It has 3 elements. All right, so to come up with all the subsets of this set, I'm going to do this in a more systematic way, and with the goal to come up with a formula that I could use to determine the number of subsets to any set. So I'm going to do this. I'm going to say, well, I'm just going to take that first element A here and kind of ask the question, is it an element of the subset? So A element of subset question mark. There's 2 possible answers to that, yes or no. So diagram it this way. Let's say, okay, yes or no. 2 possibilities. And then I'm going to take the next element, small b. And ask, same thing. Is it an element of the subset? Now, here's where we actually then begin to kind of build the formula. I've already asked the question here. So this is dependent upon that first question. That is, yes, be an element of the subset. And there's two possible answers, but two possible answers after I had answered this one, and or if I'd answered it this way. And then the same thing's going to happen when I grab the third element. I've already asked these two preceding questions. So C an element of the subset. And so off of each possibility, there are two choices, yes or no. Okay. Now, what I could do from there is follow along the paths of possible answers. And when I do that, I'm going to get all 8 subsets that we came up with last time. That is, if I go along this path, yes, okay, then yes, then yes. So there is the set itself, which was one of our possibilities. Or yes, yes, no. So that would be the subset with just A and B in it. Yes, no, yes. That would be the subset with just A and C in it. Yes, no, no. So that would be the subset with just the element A. I've exhausted all those, so I'll go to here. Yeah, no, yes, yes. So there's the subset with B and C. No, yes, no. So that would be the subset with just B. No, no, yes. So there's the subset with just C. And notice the last one. No, no, no. And that would be the empty set. And then I have my 8 possible subsets. 1, 2, 3, 4, 5, 6, 7, 8. So remember, my goal was to come up with a formula here that I could determine how many subsets there are in any particular set. So if I think about the way this would work, if I had a set with 4 elements, then I would, off each one of these, have a branch of 2 possibilities, yes or no. And then if I had one for 5, it would go the same way. Or what I notice is the number of subsets keeps doubling, that is times 2. So that if I had a set with 4 elements, there would then, if I off each one of these, I had 2 possibilities. I've just doubled it, or I went from 8 to 16. And if I had 5 subsets, I would have went from 16 to 32. 6 elements in the set, or its cardinality is 6, then I would have 64 possible subsets, et cetera, et cetera. Or another way to write doubling is we're talking about powers of 2. If there was 1 element in the set, then there would be 2 possible subsets, or 2 to the first. If I had 2 elements in the set, there would be 4 possible subsets, that is 2 to the second. If I have 3 elements, there are 8 possible subsets, 2 to the third. If I had 4 elements in the set, then there would be 16 subsets, or 2 to the fourth, et cetera, et cetera. So the number of subsets to a set is 2 to the power of n, where n is the cardinality which is simply the number, again, just reviewing, number of elements to the set. the cardinality of the set. So if you were given a set with 30 elements, you could just quickly say there are 2 to the power of 30. It'd be a big number, but there would be 2 to the power of 30 subsets to that set. All right. Any questions on that? All right. Now we talked about set equality last time, but we didn't really write a rigorous definition. But now that we have talked about subsets, we can. So we're going to say a set A is equal to a set B if and only if A is a subset of B and B is a subset of A. If 2 sets are subsets of each other, the only way that could happen is they are identical. They share exactly the same elements. All right. Now, we're going to refine our definition or refine the idea of subset to distinguish what we're going to call proper subset. All right, so a set A is a proper subset of a set B if and only if A is a subset of B. So all the elements of A are in B, but then we're going to put one extra restriction on it, and A is not B. Or another way to say that, A or B has something A doesn't have. Right? And it is denoted with that sideways U only. So the kind of the or equal to mark is gone. All right. So the number of proper subsets to a set is 2 to the n still, and just like we did for a number of subsets, but then take away 1. And the one you're not counting is itself. That's the one that gets tossed in terms of the count. So where again, n is the cardinality of the set. And introduced one more concept for today. Something we're going to, then we'll use them a good bit on Thursday. Venn diagrams. All right, so Venn, VENN, is just a guy's last name that came up with this idea. And it's a visual way to show sets and also the subsets of particular sets. Shoot. The way we represent a Venn diagram, let's say I wanted to visually show using a Venn diagram um, the complement of one set. So we draw a rectangular box. And usually you'll see them just depending upon the book you pick up, either maybe down in the bottom corner, or I usually put mine in the upper corner, but I put a scripted U, and that is to represent then this rectangular box is the universal set, everything that lives within this set. And said I wanted to visually show the complement of A. So I draw a circle. The circle represents the set A. And I usually put on the outside, but you'll see it within the inside. But the elements that belong to the complement of A, since I'm representing the complement of A here, are the portion of the box that is shaded. And so I'm shading, these would be the elements of the complement of A. And what am I shading? Everything outside of A, but still in that universal set. I know I kind of went outside there. It's just because I'm not much of an artist. And that's again what we call a Venn diagram. But we will do more with these again on Thursday. We'll use them a good bit, and then also on the following Tuesday. All right, so 2.2 problems. 2.2's got about good number of problems. And just to make sure I covered everything. All right. I'll do one. This question gets a little squirrely when we're dealing with subsets and proper subsets. I'm specifically looking at 2.2, number 11. You've got a set written as kind of C, D, E. There's a blank. And then you've got a set C, D, E, F. Okay. Now you're asked to place into here, and it's not by multiple choice. Your choices are A, I can only put that. Now that, remember, sideways uses proper subset. B, only subset. C, both subset and proper subset. And D, neither of them. So those are my four choices. And in this case, your answer is going to be C. I could actually use either. In this case, this is a subset of this, but it is also a proper subset of this, because this set, and you always read it left to right. So when you see this, you're asking, is this a subset of this set, or is this a proper subset? So again, read left to right. But I can use both. It matches up with both definitions. subset because all of these are in here, and it's proper subset because again, this one has something this does not have. So only a set cannot be a proper subset of itself ever. The empty set is a proper subset of every set except itself. So the empty set cannot be a proper subset of itself. It can be a subset. So these problems are getting you to make sure you understand the difference of the two definitions of subset and proper subset. All right, so then there would be a few problems just like this. Just making sure. Some problems finding or dealing with the number of subsets to a set. Then a few dealing, and then some problems dealing, just finding the number of subsets and the number of proper subsets to a set. So we're going to look at one of those, just make sure we've got it. If I've got a set O, P, Q, R, S, T, U, B. And this is this one's number 25 from 2.2. A wants you to find number of subsets. B wants you to find the number of proper subsets. So the first thing you want to do is find the cardinality of the set. That is, how many elements do you have? I have 1, 2, 3, 4, 5, 6, 7, 8. So the number of subsets would be 2 to the 8th. 2 to the power of 8 is 256. 2 multiplied with itself 8 times is 256. So then remember, the number of proper subsets here would be 2 to the cardinality, to the power of the cardinality of the set, but then take away 1. So it's got to be 255. Questions on that? Last few problems deal with complement. Okay. So definitely nothing in there we haven't covered. So I am assigning 2.2. Today is the 5th. The due date of Thursday, which will be 10/7. It is now assigned. So